Guys, let's do this problem right here. The question is asking to curve sketch this following equation. So they have given the equation f of x is equal to x power 5 over 3 minus 5x square by 3. So the domain. So first of all, the domain is going to be, so I begin from here. Okay, so the domain is going to be any real number because you can plug any x value, it doesn't matter. So therefore we can say domain is equal to x equal to any all real numbers. So that's our domain. So second thing is we have to find the intercepts. So in this case we have to find x-intercept and y-intercept. To find the x-intercept I have to set y is equal to 0, set y is equal to 0 and find the x, right? So if I set y is equal to 0, f of x is equal to f of x is going to be equal to 0, then 0 is equal to x 5 over 3 minus 5 x 2 by 3, and in this case what I can do is I can take 2 by 3 common. So if I take x 2 by 3 common, this is going to be 3 by 3, so it's going to be just x. 3 by 3 mean 1, right? So the x and then minus 5, so this is equal to 0. Therefore x is equal to 0 is one of our intercept, x-intercept, and x is equal to 5 is another intercept. So let's find what is the, so this is, we know this is x-intercept, therefore in this points y is going to be equal to 0. So we can say f of 0 is equal to, or we can write like this. Okay, wait a minute. Okay. We can state that this is 0 0 and this is 5 0. So this is a location, and then I had to find the y-intercept. To find the y-intercept I had to simply set the x equal to 0. So it's straightforward, because if you see, if I plug 0 for x values, it's just going to be 0. Therefore we can say y-intercept is going to be, these are x-intercepts, intercept, this is y-intercept is going to be simply 0 0. So this is x and y-intercept. Then we have to find the symmetry, whether it is symmetry or not. So to find the symmetry, what we do is we put f negative x and find this value. So in this case, if I plug negative x for x value, this is going to become negative x power 5 over 3 minus 5 negative x power 2 over 3. So in this case, if you see, this is an odd power, so it's going to be a negative value, right? 5 over 3. And the next one is, if you see, this is an even power, so the negative will become positive, and positive multiplied by this value will make the whole thing negative. So it's going to be 5x 2 by 3. Then I have to check this to be even symmetry. This should be equal to f of x. But if you see, this is not equal to f of x because we don't have this minus in this one, right? So therefore this is not even symmetry, because f of x is not equal to f of minus x. And to check whether it is a odd symmetry, what we have to do is we have to check whether it is f of minus x is equal to minus f of x. So let's check this one. If you see, this is so f of minus x, we put this one right here, right? So if it is minus f of x, what's going to happen? This is going to become minus, but this will become plus, but we don't have that one right here. Therefore this is not odd symmetry either. So this is not odd symmetry. Then I have to find asymptotes. To find the asymptotes, I have to find the vertical asymptote, I have to set the denominator equal to 0, but since this one has no denominator, therefore there's no vertical asymptote. But to find the horizontal asymptote, I have to set the limit x approaches to infinity. But if you see, if I substitute infinity for these values, what's going to happen? It's going to be infinity. And if I substitute negative infinity for these values, it's still going to be negative infinity. So there's no horizontal asymptote, because when limit x approaches infinity, f of x is equal to infinity, and limit x approaches negative infinity, f of x is equal to negative infinity. So there's no horizontal asymptote. And to find, next one is increase and decrease. To find the increase and decrease, I have to take the first derivative. So in this case, if I take the first derivative, this will become, so f prime x, this is going to become 5 over 3, and then I have to 5 over 3 minus 3 by 3 is going to be 2 by 3, right? 2 by 3, then minus, then if I take the derivative of this one is going to multiply this one, so it's going to be 10 over 3 right here, 10 over 3, and 2 by 3 minus 3 by 3 is going to be minus 1 over 3. So x power minus 1 over 3. So this is the first derivative, but to find the increase and decrease, I have to first find the critical numbers. But in this case, I have to rearrange this equation and change it in a different way to find the critical numbers. So let's see how we can do this. So first of all, what I'm going to do, I'm going to, since this is power minus 1 over 3, I can bring it into the bottom. So 5 over 3 x power 2 by 3 minus 10 over 3 x power 1 over 3. Now I can take the common denominator. If you see, we have 3 right here. So to make this denominator equal, I have to multiply this x 1 over 3 to this this equation. So if I multiply that one, the top one will become 3 by 3, so it's going to be just x. So it's going to be 5x. Then this is minus 10 over 3 x 1 over 3. Now I can find the critical numbers. First of all, if you see, we have to find the situation where this shouldn't be equal to 0, because if the bottom denominator is 0, then the equation will become undefined. So we shouldn't, we get the number that makes this bottom 0, that's going to be one of our critical numbers. So therefore we know that this is a straightforward, because if x is equal to 0, this is going to be undefined. So x is equal to 0 is a critical number, and then I have to set the whole equation to 0 to find the other critical numbers. So in this case, if I set this one to 0, denominator will be get rid of itself, because if you bring the denominator to the other side, it will multiply by 0 and become 0. Therefore I can say 5x minus 10 is equal to 0. 5x minus 10 is equal to 0, therefore 5x is equal to 10, therefore x is going to be equal to 2. So these are the two critical numbers. So now what I can do is I can find the increase and decrease. So let's plug the values here. So we have 0 and 2 as a critical number, so we have to find a value below 0, let's say negative 1. So if I plug negative 1 in this equation, what's going to happen? Negative 1 times 5 is going to be negative 5. Minus 10, so the whole value is going to be negative. And if you see the bottom, that's odd power. So if you have a negative number right here, it's going to be a negative value. So negative divided by negative is going to be positive. So below 0 is positive, so it's been increasing. And then I had to find a value between 0 and 2. So let's say 1. Let's pick up the 1 right here. So it's going to be 5. 5 times 1 is going to be 5. So 5 minus 10 is going to be negative 5. Divided by 3 times it's going to be positive value. So negative divided by positive is going to be a negative value. So it's going to be decreasing right here. Then I have to pick up a value above 3, above 2. So 2 above 2, for example 3. Let's pick up 3. So 5 times 3 is going to be 15, minus 10 is going to be 5. That's the positive number. Divided by a positive number is going to be positive. So it's increasing. And from this one, since we don't have horizontal and vertical asymptote, we can directly say this is our local maximum, because it's increasing and decreasing. So this point is going to be local maximum, and this is going to be my local minimum, because it's decreasing and increasing. So this is my local minimum. So let's find the value. F of 0 is going to be 0. We already know that. F of 0 is 0. F of 2. So we have to calculate this value. Let's see. So if I calculate f of 2, that comes out to be minus 4.76. That's f of 2. Then we have to find concavity and inflection point. To find that, I have to take the second derivative of this one. So in this case, if you see, we don't have to choose this one, because if you choose this one, you have to do quotient rule, and that's very complicated. But if you choose the top one, it's much easier, right? So this one we can find the derivative separately. Basically this one is much better. So let's choose this one, and I copy the first derivative first. F of x is equal to 5 over 3 x 2 by 3 minus 10 over 3 x minus 1 over 3. So what's going to happen if I take the derivative? This 2 by 3 multiply this one and make this one 10 over 9, and x 2 by 3 minus 3 by 3 is going to be minus 1 over 3, and then minus 10 over 3 minus 10 over 3 times minus 1 over 3 is going to be plus 10 over 9. X minus 1 over 3 minus 3 by 3 is going to be minus x power minus 4 by 3. So now I can bring this one into the bottom, and it's going to be I can take 10 by 9 common because both of them have 10 by 9. Therefore 10 by 9 common, then we have x, so we can write this one as 1 over x 1 over 3 plus 1 over x 4 by 3. So in this case, to make this denominator equal, I have to multiply this one by 3 by 3. So if 3 by 3 is basically x, so it's going to be 10 over 9, and in the top we are going to have x because 3 by 3 means x, right? So x over this one is going to be 4 by 3. Then we can simply add this one, then that's it. And from this one I can find the critical numbers. So in this case, if the what value make this one undefined, the 0 will make this undefined, because 0 is, if x is equal to 0, the whole equation will be undefined. Therefore x is equal to 0 is one of our critical number, and then I have to set the whole equation into 0. So if I set the whole equation into 0, I don't have to worry about denominator, because if I bring the denominator to the other side, it will become 0. And also the same for this one. If I bring this one to the other side, it will become 0, but this one, x plus 1. So I can directly say x plus 1 is equal to 0. Therefore x is equal to negative 1. So this is another critical number. Now we have to find the values between these critical numbers. So let's say negative 1 right here, 0 right here. So if I pick a value below negative 1 and plug in this equation, so let's see what happens. Minus 2. Let's plug minus 2. Minus 2 plus 1 is going to be minus 1. Minus 1 multiply the whole thing. The numerator is minus 1, minus value, and the denominator is going to be positive value because x power 4 is even power, right? So it's going to be a positive value. Therefore negative divided by positive is going to be a negative value. And then we have to pick up a number between minus 1 and 0. Let's pick up 0.5, negative 0.5. Negative 0.5 means 1 minus 0.5 is going to be 0.5 is the positive value divided by positive value, because even power, no matter negative or positive, you will still get positive value, right? So it's going to be positive over positive, therefore it's going to be positive. Then if I pick up a value above 0, for example 1 plus 1 is 2, divided by positive number, positive. So we know this it's going to be concave down right here, concave up right here, concave up again. So we know these are the inflection points. So negative 1 is inflection point, and 0 is one of our inflection point. And now we are ready to go. First of all, we have to find the value in f of negative 1. F of negative 1, let's see what it will be. So it's negative 6. So if you plug this one into the original function, you will get negative 6. So this is one of my inflection point, and f of 0 is going to be 0 because we already knew that we already used this so many times. So that's going to be one of our critical inflection point. So in this case, so let's begin with the graph. So I know we are going to have an inflection point at negative 1 and minus 1 and 6. So let's note the minus 1 right here and negative 6. So in this location we are going to have an inflection point, and before this happens, this is concaving down, and if you see this increasing and concaving down. Increasing and concaving down mean it's increasing at the same time concave down, increasing and concave down. So increasing and concave down. So it's going to be something like this. Increasing concave. So it's half of this parabola like this. It's increasing but concaving down. Like this, right? So that's the point right here, and we have to note the point. So at 0 we are going to have a local maximum. This is going to be a local maximum, and then at 2 we are going to have a local minimum. At 2 we are going to have a local minimum, but it's exactly at minus 4.76, so it's going to be minus 4.76 right here. So until this one it's also decreasing and increasing again. So from -1 to this one it's increasing. Also it's concaving up, so it's going to be changing like this, and then it's going to go down all the way to the here, and also we have inflection point at 0, so that's what happened here. And at 2 we are going to have a local minimum, so it's going to be somewhere right here. After that is increasing, so it's going to be turning like this and go all the way right here. So this is my graph for this question, and that's how we do this. And I hope you guys like this video. See you next time.